What's up guys, Shawnthebro here, and in today's episode of the third-person action RPG tutorial series, we are going to be going over crouching. So crouching is a fundamental mechanic in a lot of games. It can be related to stealth, or it could just be something you can do to dodge attacks or fit through openings in the world that you wouldn't otherwise be able to reach. So we will be able to crouch, walk different directions, and lock onto opponents and crouch, and we will use the same logic that we use for our standing lock on, where we face the opponent that we're locking onto the entire time, and we can walk in the given direction. So this is a full crouch system. We're just going over the movement today. We don't have any attacks associated with the crouch or anything like that. Before we hop into today's episode, if you want to get caught up in the series and check out everything we've done, I'll link you to this playlist right here in the top right corner. You can see every mechanic we've made and how you can implement your own mechanics in your own game. Alternatively, if you don't care about that and you just care about the crouch mechanic, then I'll link you to this episode right here, which will be useful for learning about how we do blend spaces. Blend spaces are really useful for our directional input. It's why we can do things like lock onto our opponent and walk a given direction while still facing them. Now with all that out of the way, we can go ahead and get started. So this is a code and blueprint tutorial series. Basically everything is done in the code today except some logic in the animation blueprint and a blend space that we create, but we also want to add an actual input that we can listen for in our project settings. So if you go to Edit, Project Settings, go to Input, then when you're in here, you have your bindings, and we have action mappings and axis mappings. Right now, I am in Unreal Engine 5. If you're in Unreal Engine 4 or Unreal Engine 5, you will be able to use action mappings and axis mappings. But if you're in Unreal Engine 5, you will get this warning saying axis and action mappings are now deprecated. Please use enhanced input actions and input mapping context as well. I have a few episodes on these topics. However, it is not required that you actually use them. So if you know about enhanced input and you're using that, feel free to create a mapping for crouch that way. But for me, I'm just going to make a standard action mapping in my project settings. So I'm going to make a new action mapping by pressing the plus here, and I'm calling it the crouch input. Then for the actual value, I just assigned it to the C key on the keyboard. We don't have controller set up in this series just yet, but you could also add a button on a controller if you'd like to account for it that way as well. Now once we've added this action mapping, we can go into our code and we can actually start binding this to functions. So basically once the C key is pressed, we can call a function on our character that will actually start our crouching logic. Now to do this, we want to go to our third-person tutorial character.h, or essentially our base character.h, whatever your base character is called. And in here, if you've been following the series, we had something called the E movement state, which kept track of if we were idle, walking, running, or doing something else. I debated putting crouching in here, and you could put crouching in here if you wanted, but I decided to make the crouching a boolean because we can crouch and be idle, right? We can be in our crouch idle. We can also crouch and walk. You might even be able to crouch and run. Some games you can crouch and then do a faster crouch walk if you're holding the run or sprint button while crouching. So everything in this enum we can do while standing or crouching, and because of that, I decided not to put my crouch in there, but instead have a boolean called isCrouching that we've added. So scroll down to your variables, and here is my new variable, bool isCrouching. I've made it a U property so that we can access it from anywhere. It's going to be important because we're going to use it for our animations. So our animation blueprint needs to be able to access this variable. So we need to make sure it is U property, edit anywhere, blueprint read write, and the category I gave it was just movement. Remember that the category is not required to be anything. It doesn't even have to be in here. The category just helps you organize your variables a little bit better. And now that we have this boolean, we need to have two functions. We want to have one function for starting the crouch or begin crouching, and one function for ending the crouch or stop crouching. So let's go to where we make our functions, and I'm making two new ones today. Again, start crouching and stop crouching. They're both void, they don't return anything. And you'll notice they are not U functions. We can't call them in the blueprints or anything like that, but we don't need to. We're going to handle all this logic in the code. 2 regular functions is perfectly fine. Very similar to how we did sprint. We have sprint and stop sprinting. We just have start crouching and stop crouching. Notice I didn't call it crouch and uncrouch. Those are functions that the character class within Unreal has by default. And our base character, our third-person tutorial character, is a child of that class. So if we called them crouch and uncrouch, we would need to override those functions or just ignore them. And then you'll get warnings in your project, or you'll have other logic that you might want to handle, and that just becomes more complicated than what we need for today. So I just have 2 functions that are unrelated to the existing crouch functions because we want to write our own logic. Now we need to go into the third-person tutorial character.cpp, go to our constructor, and the constructor is where we set all of our default values. So we want to set our isCrouching boolean to be false by default because we are not crouching as soon as we come into the game. Now I typically organize my variables as much as I can, so I have all my booleans up here, and I've set isCrouching to be false. Doesn't matter where you put it as long as you put it in the constructor and default it to false. And now we have to bind the action mapping to actually call the functions we created. So the action mapping is, again, this thing in your project settings, and we have one called crouch. So we want to bind the crouch action mapping to call the start crouching function when we press it. When we release the input, we want to call stop crouching. So going back to the code, in setup player input component, this is where we have all of our bindings for all of our actions and axis mappings. I've added 2 new bindings for this episode, both using the crouch input action. Now you can copy your other ones and just change the fields that you need, but essentially we're going to grab our player input component, which is passed into this function, and call the bind action function on it. The bind action function takes in the name of the input action, the input type, so pressed or released, the object that we're calling this function on, and the actual function that we're calling. So bind action, crouch, this name has to match the exact input action name, crouch, that we have in our project settings. So make sure that you either copy that or make sure you've typed it correctly. And you're going to want to choose pressed, IE_pressed for the first one. This, because this is the actual object we're calling the function on. And the function we're calling is start crouching, but we have to access it like this because from within this function, this bind action function is a direct reference to the function, because you could call other class functions as well. You see, we even do it earlier in our jump functions. We actually call a character : jump. So we need to make sure that we use a third-person tutorial character, which is the name of my class, : and the function we want to call, which is start crouching. Then you want to do another one with crouch, but you want to use IE_released for the type, and you want to call your stop crouching function. Now, once you've done this, we will be able to call start crouching and stop crouching when we press the C input on our keyboard, which means the next thing we have to do is create these 2 functions. So I'm going to scroll down, and I put them below my start sprinting and stop sprinting functions. Go ahead and create both of these functions now. So void class : start crouching, and void class : stop crouching. In here, I've kept the logic very, very simple for today. We don't need to make it any more complicated than this. So if we start crouching, I want our isCrouching boolean to be true. At this point, we are crouching, so set isCrouching to be true. But I also changed the maximum walk speed. Now, each character has a character movement component by default. And the character movement component handles things like gravity, maximum speed, friction, things like that. It has one variable called max walk speed, which is the maximum speed the character will move, essentially. It's called max walk speed, but really it's the fastest the character will move with our given input. So the higher we make this value, the faster they move. You'll notice if I come into my editor and I play this, if I am walking normally, this is the pace that I walk at. When I'm crouching, you'll notice that I'm actually walking slower. The crouch walk is slower than the regular walk. So by changing the maximum walk speed in the character movement component, we can also decrease the speed that the character is moving. Now, I'm using arbitrary values right now. The maximum walk speed by default on the character is 600. You can see this if you go into the character class, the parent of this class, or if you go into your blueprint with the associated character and go to the character movement component, and then look for your max walk speed, which is right here. So by default is 600, and the unit is centimeters per second. So of course you can change this and customize it to your liking. In fact, the max walk speed crouched is another variable that exists within the character movement. We don't use this because this is if we were using our crouch and uncrouch functions that I mentioned earlier. We're not doing that in today's episode, so I'm not using that variable, but you see how this works. The higher this value, the faster you walk, right? So that makes perfect sense, and if we're crouched, we want to use less speed. So long story short, I'm setting the get character movement max walk speed to 300, because I think that's a good speed while crouching. And in stop crouching, we're setting is crouching to be false. If we're stopping crouching, we are no longer crouching, so is crouching would be false. And then our get character movement max walk speed is going to be set to the default value again, which is 600. So those are your start crouching and stop crouching functions. Now, if you want, your sprint function could check for if you're crouching, and if you are crouching, stop crouching before sprinting. And same with start crouching. You could check to see if you were sprinting when pressing the crouch button. If you were, stop sprinting. That is up to you. Or you could have a faster crouch walk, which is basically like a crouch sprint. But that is up to you. That is different for each game, so play around with it, see what you like. I decided to leave it for now because I'm not exactly sure the direction I want to go. Now, the next thing we need to do is set up our blend space. Again, I have more in-depth episodes on this that I'm not going to cover all that depth, but I will show you how to make the blend space. Those videos have more depth than what we'll go into today, but I'll still show you everything you need to get started. So make sure you have crouching animations for the following. So you're going to want a crouch idle. This is your standard just crouching but not moving state. Then I have crouch walk back, crouch walk forward, crouch walk left, crouch walk right, and start crouch. So start crouch is going from standing to the crouching animation. It's just this interim animation. It makes it look a little bit nicer if you use it. I actually ended up not using it, believe it or not. I don't use it in my animation blueprint, but you can have one of these if you want. So it's good to keep the option open. Let's look at all of the crouch walk ones. So this one is crouch walk backward, and you can see he is crouching and he is also walking backward. Crouch walk forward, of course, the exact opposite, crouching but walking forward. Walk left, and walk right. So now we have all of our crouching animations. We have the 4 directions, we have the crouch idle, and you also have the start crouch if you want. You could make a stop crouch out of that by reversing your start crouch animation if you also want to do that. Once you have at least the idle and the directions though, you can make your blend space. So let's go into where we want to create our blend space. I typically put it with my animations. So I have a crouching folder where all my crouch animations are, and I made my crouch movement blend space in here. Now, an easy way to add a blend space is to go to add, and go to animation, blend space. Then you have to choose your skeleton. You'll see I chose my Knight D. Pellegrini skeleton, and that is the skeleton for my character. It's this simple. If you go to any of the animations you have, you can see the skeleton, and you want to pick the same skeleton that is shown in this animation when creating your blend space. Now once you create it, you're automatically going to come to what I have here. If you are in Unreal Engine 4 instead of Unreal Engine 5, you'll have the choosing of 1D or 2D blend space. This is a 2D blend space. It's pretty simple. Basically, a blend space with only one parameter is a 1D blend space. A blend space with two parameters would be a 2D blend space. We need the direction and the speed for this blend space, so it is a two-dimensional blend space. Now, I don't have to make a new one here. I already have one, but I'll show you how to add animations to this blend space so you can get the hang of it, and then I'll show you what my final blend space looks like. So let's go ahead and bring this here, and now that we have our blend space created, we can add animations from the asset browser, just as it says in this little tip right here, and we can put them at the speed and direction that we expect. So essentially, if we are not moving, if we have a speed of 0, we want to be in our crouch idle. If we are moving, great, we want to show our crouch walk, but what direction do we show? We need to account for the direction. So we have our direction and we have our speed, and those are going to be our axes, our horizontal and our vertical axis. So the easiest thing to do is open up these two axes and give them a name of direction and speed. Now I'm going to open up the blend space I've already done, and you'll see I have direction and speed. Now, these other parameters are all really important, which is why I want to use this one that I already have so I can explain them. Now, for direction, we have a minimum and maximum axis value. We need 360 degrees because the character can turn all 360 degrees and they can move all 360 degrees. However, we use negative 180 to 180 because if you use 0 to 360, you don't get the same effect that you will with negative 180 to 180. If I am standing completely still looking forward, we're going to say that is a axis value of 0 for the direction. If I look to my left, that is typically considered a negative value, so I could be negative 5 degrees. Now, yes, it's true that that is 355 degrees. That would also be accurate. However, as far as the blend space is concerned, it knows it will now have to move from 0 to 355 degrees. And so if you do that, the character may flip around the other direction. He may flip around to reach the 355 degree mark, where really we just want him to turn to the left. Long story short, using negative 180 as the minimum axis value will allow us to look from forward all the way down to behind us. And then 0 to 180, the maximum axis value, will allow us to look from 0 all the way down to behind us. So negative 180 is front of us to the left to completely behind us, and 180 is front of us to the right to completely behind us. Now going back to the new blend space that we made, you can see everything else in here. The grid division, snap to grid, all the way down to the ending of the horizontal axis is all the same. So the only three variables you need to change are the name, minimum axis value, and maximum axis value. So name of this is direction, minimum axis value is negative 180, and the maximum axis value is 180. Now the vertical axis is our speed, so we can go ahead and put the name of speed in here. And now these values are a little bit more up to you. You can change them to your liking. So these are your speeds that the character is going to be moving. Now the minimum axis value is going to be 0. There's not going to be a direction. Speed does not have direction. Velocity has direction and speed, but speed itself is just a flat value. So the minimum axis value is going to be 0. The maximum axis value should really be how fast your character can move at the absolute maximum. We have 600 when uncrouched. This is our crouch blend space that we're making. So you could put it at 300. That is our maximum walk speed while crouched. But you could really put it as high as you want and it won't affect anything as long as you account for it properly. So let's go back to the other blend space, the one that I've already set up. See, I have speed 0 and I have 1500 as the maximum axis value. I have this because the sprinting character speed is 1500. But if I make it 300, you'll see that this still works perfectly fine. I can still move all my directions, and I still have crouching idle. We got a bunch of errors when we did that because it removed all the other nodes that I had set up for 1500. And I'm not worried about it because I don't need speeds that high. I need speeds of 0 to 300. One other thing to note while we're in here, notice that whatever you see on this grid isn't all that exists. If I change it back to 1500, these are still here. Now that we have made that point, we can go ahead and delete these. We don't need these ones that are at 1500. So I'm actually going to change my maximum access value to 300 like we saw, and that still works. So if I play the game, you're going to see the same result you saw earlier in the episode. Okay, so everything still works. I had changed the grid divisions to 8 for the vertical axis. That is just because the values were so different. Since I have changed it down to a maximum axis value of 300, I can keep the grid divisions at 4. Just take note of what these do. We have our first grid division here, second here, third here, fourth here. If I make this 20, we're going to have a lot of divisions on this graph. They default to 4 in a blend space, and 4 is fine for today. So now going back to our new blend space, we already have our values set up. So you can see that's all I did in my blend space. I set up those values for my axes. Now what we have to do is add the actual animations to make it play with that direction and speed. What animation do we want to play? So speed is our vertical axis, direction is our horizontal axis. Now if speed is 0, we just want to play our crouch idle. We're not walking. So we just need one animation here, which is our crouch idle, and you can literally drag it in. You might get an incorrect direction and speed if you're not setting the axis to snap. So in your axis, you can say snap to grid, and it will snap to more reasonable settings. It'll snap to the divisions. Up to you if you want to use that or not. What I like to do is just manually click on them and set them to 0.0 or whatever values I want and not use the snap, but that's just personal preference. And so I have direction of 0. So now you can see the character is crouching and they're in crouch idle. As I change the value here, wherever the green X is the value that I'm giving to the blend space. As I change it, you can see nothing's happening. Now what we want to do is if we were walking, we need to play a walking animation. Remember, direction is very important here. Now let's assume walk forward is the one that we want to pick. Let's add our walk forward animation in. And I'll go ahead and set the values direction of 0 and a speed of 300. Now, as I go to walk here, you can see he goes into his crouch walk animation. The way you test this is by pressing Control on your keyboard and moving your mouse. You'll be able to change the value that is being passed into the blend space. So if I come all the way over here, give it this direction, then it never moves. He's still just walking forward. Now, if we use this blend space, we would only ever be able to walk forward, so even if we were walking left or right, he would still be using his legs like this. We need to incorporate left, right, and back. Now, remember what our direction values are. So this is a direction of 0. This is directly in front of us. Now, the negative 180 and to the left is walking to the left. So we want to use crouch walk left. We can put it right there. And I will give it a direction of negative 90 and a speed of 300. Now you see, as we reach that speed, he is crouch walking to the left. As we turn, he is walking forward. All right. Now we want to do the same thing for walking to the right. So let's add crouch walk right, and let's give it a value of 90 for the direction and a speed of 300. Now the character is walking to the right. And as I slow them down, it's all crouch idle still. Okay. So it only matters when we're walking, and the direction changes what way his legs are moving. Now, if you want to do backward, you need to reach either negative 180 or positive 180. So we want to add a crouch walk back to the left. Let's give it a value of negative 180 and a speed of 300. And now you'll see we're walking forward, walking left, walking backward. However, we can't just leave it there. If we do, we won't be able to walk to the right and then walk to the back. So if we're walking forward, we start walking right, perfect. But as we keep turning, we get stuck at right. So it has to be on each side. So direction of 180, speed of 300. Now we can either be crouch idle, walking backward, walking to the left, walking forward, walking right, and walking backward. And that is really all there is to it. So you're using your direction and your speed to change how the character is animating. Now, in the other example I had shown, the one I'd already set up, I did have extra in here. I technically had a bunch of extra crouch idles. That's because you could have different directions at each one of these idles if you wanted the character to actually turn that direction or orient themselves differently. Even though they're not moving, their direction can change without any speed. You can rotate, you can turn and look a given direction. In our specific case, the character is either locked onto something, which is making them look there, controlling their direction, or they are able to rotate freely. So it doesn't really apply here, and I don't need these. But just take into account that you could use them if you wanted to rotate your character, even if there was no speed. I don't need to, so I'm perfectly fine leaving it like this. We're good to go. And now, because of that, I don't need my new blend space anymore. They're exactly the same, so I'm going to delete the new one and just use the old one that I already had. But now we've fully remade it. With that done, now we have our blend space. We need to go to the character's animation blueprint, because if we do that, then we are able to add the blend space, and then we can actually show it on the skeleton when we're playing the game. So really all we need is the state machine. We don't have to change anything in the event graph or anywhere else. We just need our state machine, and we need our transitions from the state that we're in to our crouching state. Now, if you've been following the series, you will have everything you see here. If you've been following my blueprint only input buffer tutorial series, you'll have these added 4 nodes. So the only new node that you have is this one right here. So I have my idle and my move, which handles my blend spaces for all my standing movement. It gets a little bit more complicated because I have weapons included. We're not going to go over holding the weapons today and having different stances with those weapons when we're crouching, but that is something we will be covering. But the crouch is more simple for right now. So what we're going to do is add a new state, and you just right click and type add state. And I called this one crouch idle / move. All right, and then once you do that, you can connect idle move to crouch idle move and crouch idle move back to idle move. So basically you can transition from standing to crouching and crouching to standing. And all we need to do to transition between these states is check to see our is crouching boolean and determine if it's true or false. So go into idle move to crouch idle move, and I have a character reference that we set up in the event graph, and this is just the owner of the animation blueprint. I can go to the event graph and show you that. Right here in either begin play or in our blueprint update animation, I get the owner of the animation blueprint, cast it to our base character BP, which is my character blueprint, and then I set my character reference to that value. So I'm grabbing my character reference, pulling off of it, and I'm grabbing my is crouching boolean that we set up in the code earlier. And then you can drag that into the result. Basically, if we are crouching, then we go from idle move to crouch idle move. Now, crouch idle move back to idle move is the exact opposite. We grab our character reference, we grab the is crouching boolean, but we specifically want to make sure that we are not crouching to return to idle. So you can drag off of is crouching and type not boolean. You'll get this node here, and you just return that into the result. Now you'll also see I don't have any transition events or anything hidden here. That's all there is to it. Now we have to set up the animation on the event itself. So go into your crouch idle move, and it's very simple. we are going to want to pass in our crouch movement blend space that we made earlier. Pass that into the output animation pose. But you'll notice there's a direction and a speed that have to be factored in. And so I already have these two variables from earlier in the series when we did our standing idle move blend space. But to calculate these is very simple as well. So I do it in my tick function, which is the blueprint update animation event. And we follow this logic around. And right here, this is from the default animation blueprint logic. I didn't even add this. All I did was set it to a variable. So we have the velocity of the character. Then we're getting the length of the vector, which really just gets the character speed for us. So I'm setting get velocity of the pawn owner, so basically the owner of the animation blueprint, vector length to the character speed variable. And if you don't have a character speed variable, well, simply enough, you can drag off the vector length, promote to variable, and it will make a character speed float variable. Then additionally, off that same try get pawn owner, we use get actor rotation alongside the velocity that we got from it to calculate the direction the character is moving. At this point, we can store that direction in our character direction variable, which is also a float. So we have our get velocity, we're going to use get actor rotation, and we're going to call a function calculate direction. You pass in the velocity, pass in the rotation, and you will get a direction. Now you can use this one, or there is another calculate direction, which is actually the one I used. They are essentially the same. They are a little bit different because they are referring to different objects. So calculate direction will refer to any velocity and rotation you give it, whereas this one is specifically for the animation instance. In this case, they will do exactly the same. So it doesn't matter which one you pick, but just take note of that if yours looks a little bit different than mine. And we take the return value and set that equal to our character direction variable. Now everything else in here is stuff we do for weapons and unrelated to this. So if you didn't already have those variables, now you should, and now you can pass in direction to direction and speed to speed. At this point, your crouch movement blend space will have those parameters passed into it, and so you will be able to actually move and change the values of that blend space once you enter that animation. So as I crouch, I can move, and I'm only moving forward here, right, because I can only move the direction that I'm looking. But when I lock on to my opponent, I can walk right, left, back, and forward. I can also walk diagonal directions, and that works perfectly fine because blend spaces are great for that. Alright, now I've equipped my sword. You'll notice I can crouch, and it does work, right? It fits perfectly the way we set it up. It's just we don't have separate stance animations or attack animations for crouching, so we can't do anything with it. But the attachments will work, and your weapons and armor will stay. So that is not a problem. Anyway, guys, that's all I got for you today, so thank you so much for watching. If you enjoyed, please subscribe, and please consider following me Patreon or YouTube membership, like all these kind souls have. You guys are awesome, and I'm so excited to continue making this content for you. If you had any issues following this tutorial, feel free to join the Discord community. There's a link in the description, and I'll be happy to help you out. That is completely free. But otherwise, guys, that's all I got, so thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.